Hello, these are the notes for section 5.4, which is multiplying with radicals, conjugates, and rationalizing radical expressions. These notes go with the 5.4 worksheet, which is assignment number 34. We'll be doing the odds on that the first time through. Okay, so we're going to be doing a little bit of review because we need to remember where we've been so that we can understand where we're going. So one of the multiplication scenarios that we've done are monomials and monomials. So let's start with just multiplying, regular multiplying. And we'll start with an older example, perhaps. Let's say you have 2x radical 3 times 3 radical 7. When you multiply two monomial radicals, you always multiply the scalars together first, and then you multiply the radicands together second, and then always double check that the radicands are simplified, because oftentimes when you multiply you have a new number and it may simplify out. So 2x times 3 is 6x for the scalars. Inside the radical you have 3 times 7, which is 21. 21 does not have any matching pairs of factors, so we are done. All right, that's the kind of multiplying that we've done so far. In this exercise, we're going to be doing binomial multiplication. So square root of a plus 2 square root of 3 times 3 square root b minus 4 square root 3. Now, if it was just a monomial being multiplied by a binomial, like this, you would just distribute the 2 radical 3. But this is indeed two binomials. So we're going to use distribution method. We're going to start with the first radical, radical a, and we are going to distribute it through the second set of parentheses. So mentally, you want to think scalar, scalar, radical, radical. Well, radical a doesn't have a scalar, so that makes it easy. 1 times 3 is 3. Now radicands. A times b is ab. Moving to the next one, scalars. 1 times negative 4 is negative 4. Now radicands, a times 3 is 3a. I don't usually worry about simplifying until I'm done multiplying, because get everything together and then work on simplifying. Now we're going to take the second term and distribute it through the second set of parentheses. Again, we're thinking scalar to scalar, radicand to radicand. So 2 times 3 is a positive 6 for the scalar. Radicand 3 times radicand b is 3b. Moving on. Scalar 2 times scalar negative 4 is negative 8. Radicand 3 times radicand 3 is 3 times 3 or 9. Once you have everything multiplied out, now we want to simplify. Well, the only one that simplifies is this last one, because 9 is actually 3 times 3. So 2 3's, 1 comes out, it gets multiplied by the 8. So it's negative 24. No more radical. Now, as far as writing your answer in correct order, it's generally accepted that you write rational terms first and then irrational terms second. So the only rational term we have is the negative 24 because it doesn't have a radical. So it's going to go first. And then generally we go with the radicals after that. If it's clear that one of them has an A, the next one has a B, the next one has a C, it's pretty straightforward. But think about how we did ordering. Plain before peanut. So plain A, so negative 4 radical 3A. Now peanut plus 3 radical AB, because it mixes the A's and the B's. And then last 6 radical 3b. So that would be the way you order. You order on rational first, then irrational, and then after that you just follow your normal polynomial rules of order. And since there were no scalars with variables, you go with the scalars inside the radical. All right, so that's multiplying with the new style of problems. Topic number 2. We're going to first develop a math tool and then we'll use it. The tool we're going to develop is radical conjugates. Radical conjugates. Okay, so for a radical conjugate, there is a pattern. The pattern is if your original number is a plus b radical c, your conjugate is going to be a minus b radical c. The conjugate is identical. Excuse me, let me move this up. The conjugate is identical except for the middle sign. If this one is positive, that one is negative. If this first one is negative, the second one is positive. Notice that in both cases, the a is positive. So the first term doesn't change, just the second term. All right, so the purpose. Why do we want to know conjugates? Conjugates are used to multiply out irrational values. And the mechanics of that are pretty simple. When you multiply a number by its conjugate, the radicals automatically simplify out. So here's an example of that. 2 plus square root 7 times its conjugate, 2 minus square root 7. As before, we're going to use distribution. 2 times 2 is 4. And then we're going to multiply here. Remember, scalar first, radicand second. So 2 times a negative 1 is negative 2. And we just tag that radical 7 on. Now we go to the next term and we're going to distribute it. Again, scalars first. 1 times 2 is 2. Tag that radical 7. And the last one, a positive 1 times a negative 1 is a negative 1. And we have radicand 7 times radicand 7. So 2 7s under the same radical. When you multiply conjugates, the middle two numbers, if you're using distributive process, should add up to 0. 2 radical 7 minus 2 radical 7, those indeed add up to 0. You will oftentimes find this will simplify out. So 2 7s, 1 comes out, it gets multiplied by the negative in front. Bringing the 4 down, we have 4 minus 7, which is negative 3. And this is rational because it has no radical. Okay, so we're going to do a little bit of practice on writing conjugates to make sure that you've got it. So I'm going to give you 2 binomials and I want you to write the conjugate next to it. All right, here we go. So a little bit of practice. Negative 3 plus radical 2 is your first one. And then your second one is square root 17. I want you to go ahead and write the radical conjugate of the number. Go ahead and do that. I'll give you a few seconds to come up with an answer. Okay, for the first one, the first term does not change. That's still a negative 3. The second term changes sign, so it goes from positive to a negative radical 2. Now for radical 17, it might be helpful to think of it like 0 plus radical 17, and then do the conjugate with the 0 and the plus in your number. So the 0 will stay the same, and it will go from a positive radical 17 to a negative radical 17, which of course is just negative radical 17. So those are your conjugates. All right, now that we have practiced doing conjugates, we're going to start to use them. So Roman numeral 3 is division of radicals. And I'm going to put division in quotes because it's not traditional division that you have already learned. It's division using conjugates. So when you divide radicals, what you're really doing is rationalizing. And for that, you're going to use conjugates. Now, we've done rationalizing with monomials, but we have not done it with binomials. So this is a little bit different. Here's an example. 2 divided by 3 plus radical 5. So first thing you're going to want to do is stack this up into a fraction. So 2 divided by 3 plus square root 5. So when you rationalize, you eliminate all radicals from the bottom of the fraction. You can't divide by a number you can't define. And any number that is trapped in a radical is automatically a non-repeating, non-terminating decimal. So it has no set value. That's why it is irrational. So we're going to start by multiplying the bottom by its radical conjugate, which is 3 minus square root 5. Now, just like the rationalizing we've done before, you can't just do that to the bottom of the fraction. You must also multiply by the same thing on the top, 3 minus radical 5. So on the top, you're just going to distribute the 2. So 2 times 3 is 6. 2 times negative radical 5, think scalar. 2 times negative 1 is negative 2. Tag the square root 5. On the bottom, we're going to multiply out, and I'm going to do it in a line, in a row. So 3 times 3 is 9. 3 times negative radical 5, scalar first. 3 times negative 1 is negative 3. Tag the radical 5. Move to the next term. Radical 5 times positive 3 is positive 3 radical 5. And then last one, radical 5 times negative radical 5, a positive times a negative is a negative, and the two 5s get combined under the same radical. So as before, when you multiply two conjugates, the middle terms will add up to 0, and we have two 5s, one will come out, so we actually have a negative 5 and no radical. Let me rewrite the top, 6 minus 2 radical 5 over 9 minus 5, which is 4. Now here is one of the trickier parts of simplifying radicals is oftentimes when you've changed the way the fraction looks, there's more that can be simplified. We've done this before, but if you can divide a number out of the scalar and the head term, and that number is a factor of this monomial, it needs to be canceled out. So if I put these two in parentheses, I can divide a 2 out of both a 6 and a 2. So I'm going to put the 2 in front. That leaves me with 3 minus radical 5. On the bottom, I have 4, which factors into 2 times 2. Now I have a monomial 2 over a monomial 2. They cancel out. And all I have left on the bottom is a 2. So 3 minus radical 5 over 2. As always, there are standard forms of answers. The standard form of a radical answer is a plus or minus square root b. Rational number comes first, irrational number comes second. So we're going to split these two terms, each one over its own 2. So 3 over 2 minus radical 5 over 2. And that is your answer. Okay, so that is rationalizing the bottom of a fraction. Moving on. Example 2. What if you have a binomial on the top and a binomial on the bottom. It actually doesn't change the process that much. You just have a few more radicals floating around. So we're going to divide 4 radical 2 plus 5 radical 3 over 4 radical 3 minus radical 2. So remember, when you divide, you're actually rationalizing. So we're going to rationalize the bottom. We don't care about the radicals on top, only the bottom. So I'm going to multiply the bottom by its conjugate. Well, the conjugate is 4 radical 3 plus radical 2. And of course, if I multiply the bottom by that, I must multiply the top by the same thing. 4 radical 3 plus radical 2. Now we multiply like crazy. Here we go. 4 radical 2 times 4 radical 3. Scalars first. 4 times 4 is 16. Now the radicand, 2 times 3 is 6. Distributing to the next term. Scalars first. 4 times 1 is 4. Radicals second. I have 2 and a 2. I'm just going to leave those separate because I know they're going to simplify out. Now distribute the second term. Scalar first. 5 times 4 is 20. Radicand second. I have a 3 and a 3. Last one. Scalar first. 5 times 1 is 5. And inside the radicand, 3 times 2 is a 6. Now let's do the bottom. 4 radical 3 times 4 radical 3. Scalar first. 4 times 4 is 16. Square root of 3 times 3 in the radicand. Now we distribute to here. 4 times 1 is 4. Radicals next. 3 times 2 is 6. Moving to the next term. Negative 1 times 4 is negative 4. Now the radicands. 2 times 3 is 6. Last one. Negative 1 times positive 1 is a negative 1. Radical, and the radicands are 2 and 2. So right away you see on the bottom these middle two terms add up to 0, which is what we wanted. And we've got some things that are going to simplify. So I'm going to go ahead and take a simplifying step. 16 radical 6 is not going to simplify, but on the next one, 2 2's, 1 comes out, 4 times 2 is 8. Next term, 2 3's, 1 comes out, 3 times 20 is 60. And then we have a positive 5 radical 6. On the bottom, 2 3's, 1 comes out. We're going to do 16 times 3, which is 48. Those canceled out. 2 2's, 1 comes out, gets multiplied by the negative 1, so it's a negative 2. All right, now we can do like terms. 60 plus 8 is 68. These are both radical 6's, so we can actually add those. 16 plus 5 is 21, radical 6. On the bottom, 48 minus 2 is a 46. All right, so I think there might be some more things that can divide out. If you're not sure how to do the last simplifying step, the way I showed you on the other problem was to divide out of the monomials on top and then cancel with factors on the bottom. Here's another way to do it if it makes more sense. We already know that we're going to show our answer in standard form, which is some number a plus or minus a radical b. So you can separate first and then simplify. So I'm going to put each of these over their own 46. So 68 over 46 plus 21 radical 6 over 46. Now 68 and 46, let's see, 46 is 2 times 23. 23 is a prime number. So really the only factor they might have in common is going to be a 2. So 68 is 2 times 34. 34 is 2 times 17. So they do have a 2 in common. So I'm going to end up with 23 over 34. On the second one, 21 is 7 and 3, neither of which are factors of 46, so it does not change. 21 radical 6 all over 46. This would conclude our note taking for today. Remember that we will be turning in notes at the end of the semester, so be sure and keep track of them in your binder so that you can find them when it's time.